Good afternoon, ladies and gentlemen. You're all very welcome to today's webinar on our MasterSeries 2014 major release version preview of our new features and enhancements to this edition. My name is Martin O'Gara. I'll be presenting the most of the webinar here today, and also joining me for a little bit of presentation as well as my colleague Michael Dowd. So just a little bit of housekeeping before we begin to make sure that you all can hear me. Can you all please click on the little raise hand symbol to ensure that you're receiving me loud and clear there? Great. I think I'm getting enough hands there to ensure that I'm not talking to myself. Brilliant. So we'll just drop all those hands. So as I say, we're here today to see what's coming, what new features we have to offer you in our MasterSeries 2014. Once again, it's been a very busy year for MasterSeries in terms of moving forward with developments, and we're just going to give you some of the highlights of what we've been doing and what you can expect to see in the 2014 version. The 2014 version will soon be available within the next week or so as a pre-release beta copy. So if you're interested in participating in our beta testing program, you can email us, let us know. We'll pop you on our list and we'll give you a beta version very, very soon. Thereafter, we don't have long periods between beta testing and general release. So we're hoping to have this product, the 2014 product, available to everyone on a general release, certainly within the next 3 to 4 weeks. So we'll press on and show you what we've got here today. So our MasterSeries 2014 has had a significant under the bonnet upgrade in this edition to make it a 64-bit compatible application. Obviously that will run, how that will pan out is basically you don't need to think about that. There'll be a one installation for the product. It will run on a 64-bit machine as a 64-bit application, and on a 32-bit machine as a 32-bit application. So if you're still on a 32-bit operating system, don't worry, you'll not get left behind there. Naturally, following on from that there, we spent a lot of effort in this development year implementing the IFC standard. For those of you who aren't familiar, we'll talk a little bit more about that, but it's an industry foundation class. It's a common set of data schema which many software houses, right from Google SketchUp all the way through to Revit, etc., all implement the IFC format for exporting and importing. So that really opens up the MasterSeries to a wide range of applications in terms of being able to share data to and from. We've got some major enhancements in our MasterSeries Revit integration. We'll be going through those in quite a lot of detail. We'll be going through some new features in our MasterFrame finite element analysis. We'll also be introducing the implementation of our torsion design to Eurocode in SCIP 385. We've always had the SCIP 57 publication. However, the 385 extends that and does some additional components and on the back of P57. So that's been implemented now as well. Some new features in MasterFrame, and then we'll also be looking at a review of our MasterFrame dynamic and seismic analysis features. Basically, throughout 2013, we introduced quite a range of significant and new features prior or after, the major version increment that we released in May. From that point onwards until the end of the year, there was a number of other significant new features which came out during that period. So naturally, many of you may not have had the opportunity to pick up on those or be introduced to those, and we'll be reviewing what some of those were today as well, because those fall into basically the last 12 months of major development works. Maybe not of a great deal of interest to a lot of people, but for some people this is quite important, in that we are changing our installation package to move away from what's called an install shield type package to an MSI installation package, and for many people who are in the business of deploying the MasterSeries over a wide number of workstations on their network, that's particularly important to them. So the MSI installation was something that you'll be looking forward to there, as well as continued updates of the software with MSP patches. So both installing and updating MasterSeries applications on a wide range of network or workstations on your network, hopefully for a lot of people, will become much simpler. So we're going to talk a little bit about what we've done to MasterSeries 2014 for 64-bit. Now, unfortunately, for the 64-bit, we have had to implement a lot of under the bonnet updating of technologies. And I say unfortunately because it involves quite a lot of work for us, but at the end of the day, for maybe not an awful lot of perceived benefit or new feature for you guys, the user. But obviously, the major benefit for you is that we are updating our technologies and future-proofing the software for hopefully decades to come. So there's been quite a considerable amount of that. Some of these technologies that we've worked on is implementing a newer version of the Microsoft .NET framework. That in itself will allow us to do things and implement or take advantage of parallel processing in a much easier fashion. We have also implemented a new DirectX technology, which still uses DirectX, but we're moving forward in the platform that we use for DirectX. Really, what that means for you guys, the user, is not a lot for this 2014 version, but we basically are in a position now where we can move forward to DirectX 10. We could have done that quite easily for this issue. However, the main disadvantage there would be that DirectX 10 isn't supported by older operating systems such as XP. Now, XP is it's end of life and ceased to be supported by Microsoft. So I think now is a good time, obviously, for a lot of people to be moving away from the XP operating system. But by 2015, we will be in DirectX 10, and the XP operating system won't be supported. We've also updated a lot of our databases to move away from our existing database technology, and all of your existing steel section databases, user section databases, will all be upgraded automatically during the installation process, so you don't really need to worry about that. For you guys, the user, if you are running the MasterSeries on a 64-bit PC, as I say, your application will run as a 64-bit application from 2014 onwards. Maybe contrary to popular belief, the 64-bit application won't necessarily give you great speed enhancements. However, the main advantage it will give you is access to a much larger array of memory. 32-bit applications are restricted to 2 gigabytes of memory, which might seem like an awful lot, but believe you me, when you're doing some big frame analysis statically, and certainly when you're doing large frame analysis dynamically, the memory requirements are quite colossal. The 64-bit operating system will lift the lid on the size of frames that particularly people are able to cope with in the dynamic analysis. So that's the main advantage you're going to get from that work, as well as I say, the future proofing of the product and moving forward with the latest technologies. Going to start, obviously there's not a lot I can show you there on that. You just got to take my word for it that a lot of effort went into, as I say, moving forward with the underlying technologies. We're going to talk first of all about the IFC, importing and exporting. As I mentioned at the beginning, IFC is the accepted industry standard for common data exchange between BIM authoring tools. So really any BIM authoring tool that you might use, whether it's Tekla or perhaps some of the other ArchiCAD products or something like that, those will all have an IFC ability to export and import in IFC. So basically, it opens up the ability to exchange data with MasterSeries with a wide range of applications. We're using IFC 2.3 with Coordination View 2, which is pretty much what everyone. The Coordination View is basically a certain subset of the IFC, which makes it applicable to our types of applications, i.e. building structures and the likes. So this is what we're using, and indeed that's the common that all other software that deals with building modeling will use as well. So that's going to bring us in line with all of that. But looking forward, I mean, what we have at the minute and what we look at is the ability to both export and import to IFC and import from IFC. So you can get your models from MasterSeries in an IFC format, or you can import a MasterSeries and generate a MasterSeries model from an IFC file. We'll show you both of those. Naturally, the other question is, what about round-trip integration? can we do a round trip type of integration? Well, the answer is not today. Basically, how all of that type of change is managed and is something called model servers, BIM model servers, and IFC is certainly the language that's used for BIM model servers. Now they're very much still in embryonic stage in terms of take up of BIM model servers, but it's certainly the implementation of the IFC places us well to be a part of that change moving forward, of where you've got a centralized BIM model which is stored in IFC format, and we both take information from that and submit information to it, and it manages the round trip integration. So that's really the future, and this is why we feel that the IFC is a very important thing for us to get on board with at this stage. Next we're going to talk about Revit. So I want to show you a little bit about this IFC importing and exporting first of all before we go anywhere. So I'm going to show you here, and there's many different free IFC viewers you can get your hands on. This is one called IFC Story Viewer, and I have a model here which is kindly sent to us by one of our users, and it shows you a structural model which is in IFC format, and I'm looking at it in this IFC viewer, and it's all very nicely presented, and we see all our members and their connectivity. However, the IFC format does present a certain number of challenges for us as structural engineers, and the people, the implementing group for IFC will admit that the IFC format primarily has been driven by the architectural side of things and less so by the structural and mechanical. To which end, what we get, or what we're looking at here in the IFC, is a model which is very much schematically connected. You can see here the end of this beam doesn't really connect to the end of this column, and everything is cropped short as we would do ourselves in any drawing. But what this IFC model doesn't provide us with is the connectivity information. Now this is a common problem we've actually had, even not just with IFC, but other open standards such as the DSTV 96. We would import something from some of these types of data exchanges to end up with a MasterSeries model which was very much unconnected, and that's something we've had to think an awful lot about. Let's show you that. I'm just going to take that model into MasterSeries, and we're going through the normal route of how we import stuff to create a new master frame model. So we've now got the import IFC, and I'm just going to get myself out to this file, Clyde Valley, which is the one we were just looking at, and I'm going to uncheck this auto connect geometry just to show you there. So let's just extract that. And as you notice here, actually we can import, their IFC has the ability to cope with a wide array of objects and data types, and we can import IFC slabs, IFC walls, not to mention grid lines and level information can all be imported from the IFC file as well. So that's imported now, and we're just going to load that file into MasterSeries. So just to note that I didn't go for this auto connect geometry, and now we're importing exactly the geometry that we saw just a moment ago in the IFC file, and we can see, if I just turn on my DirectX, that indeed we have a major problem on our hands, in that nothing really is connecting in the way that we would want it to. Not to mention, obviously, we've got other issues such as beam levels obviously coming in at their center lines, and you've got a step here where you've got differing section sizes. So you can see the lining up of the top flange all looks beautiful when you put it on 3D in terms of the cropping and everything. However, that for us as structural engineers is an absolute nightmare. I think we would spend more time trying to fix that model than we would do just creating it from scratch. So as I say, that's something that we've put a lot of effort into to getting right for you, basically. So we come here again, and this time when we import, we're going to go for this auto connect geometry, and we'll just extract that. It will take a little longer this time. This auto connect geometry, very clever stuff. We've done a lot of work in terms of looking at these 3D objects and looking at their clash detection and seeing which objects collide using collision detection, theories and such, and following which we spent a lot of time refining and fine-tuning a very clever algorithm to look at how we would want to connect this stuff together. So we can see here now a much better place to start from in terms of moving forward. So things like, you know, the way this member would have been taken in as one member, we've automatically created that as a super member for you. The same thing, this would be a super member in terms of a drafting super member for your column. These are all things obviously that you're familiar with other types. You know, when we're doing Revit imports and exports, we do those types of things as well. So that's an excellent model there for you to begin with and to begin moving forward with. So we're very pleased with the AutoConnect geometry techniques that we have there, and the time that will save you will be invaluable. Interestingly, the IFC format or standard in itself does have the ability to hold structural analysis lines as opposed to physical objects or physical members. However, the IFC, many people export an IFC, but it is not compulsory for other applications to provide that information, and indeed many other applications wouldn't even have that structural analysis lines type of information. So it's certainly not something that we're seeing coming through in the IFC, so we're having to resort and rely on our own technology here to try and make these models work for you guys. So that's going to be very useful there for you. So as I say, this opens the door to a wide range of applications. Now, I want to show you something else just on this score of IFC, and that's the exporting in IFC as well. So if we come into here, IFC, I have another model here. You've seen this model perhaps in different occasions and different webinars, but we've got a nice model here of a mixture of slabs and walls and different types of materials. And just to show you the exporting procedure, very simple, IFC and simply export IFC, and that will export the entire model. And if I come along to my little viewer over here, let me just close that down, and just on my other screen I'm going to open that up. Okay, and let's just get that available to me, and I'll just swap that across to this screen, and let's put it on a view where you can see it, and we can see now everything coming in. So this is your export to IFC, and now I'm presenting that in the viewer. And well, I'm looking at a 3D view here, but if I come along and show you the other part of the viewer, which basically shows you all the levels which have been exported as well. So this is a level called ground beam, another level called transfer slab, and these are all the different objects that we are indeed exporting there. IFC as well has GUIDs, object information presented on every single member. We retain that GUID as a way of identifying those members in MasterSeries. Given that this is an export, I'm not quite sure that would have been stamped with those GUIDs, but you can, no, we haven't stamped it, but certainly our model that's been imported would be stamped with all of those GUIDs, and you would be able to see those GUIDs in the member information. So that's our IFC. I want to come forward now and talk about the next part of our little presentation, and that's indeed our Revit new features. Perhaps one of the most significant new features that we have on our MasterSeries 2014 Revit integration is the introduction of 32 new MasterSeries generated Revit families. Now these are all families that we sat down and wrote from scratch to basically to accommodate a wide range of sections that we previously weren't able to export to Revit. Namely things like our haunched sections. There was no haunched section family in Revit. Also in MasterSeries you have the ability to say that a section is a double section, and without actually just exporting that double section as two separate single sections, there was no way of doing that, and doing it that route as well presented a number of complications in terms of the continued bidirectional linkage. So we now have double section equivalents for all of our standard sections. We've also got all the compound type sections that we can deal with in MasterSeries, but again would have been more difficult to deal with in Revit, such as an I section with a channel on top. We've also got the eye sections plus with another eye section coming into their minor axis. The same with hollow sections, and also our plated eye sections, not our built-up eye section, but a rolled eye section with an additional plate on the top or bottom. So those are a wide range of sections we have there. Over and above that as well, there was many occasions when we would export to Revit and we would look for a certain, let's say, UB section size in the standard Revit catalog files, only to find that that particular section we had in MasterSeries wasn't in the Revit, and then you guys on the Revit side would have been giving a warning about that, and you'd have had to go and find that section. Now we're actually exporting all sections with their actual dimensions, and if they're not found as a catalog file, we will create the equivalent section using the appropriate Revit family from those section dimensions. So there should be very little missing sections or sections that we've failed to create in Revit going forward. We've also got some nice improvements in terms of level integration, which I'll show you in just a moment. Also, we've got the finite element surfaces now being able to go from MasterSeries to Revit. You could go from Revit to MasterSeries with Revit slabs and walls to FE surfaces in MasterSeries, but not the other way, and we're doing that for you now as well. So let's have a look at some of those. So I want to open up a model here that I have in my Revit directory. It's a very simple little model with a variety of section types. And what we have here is simply some haunched sections, and over here on the end we've got a portalized bay, which basically has an eye section with another eye section coming out of it from the minor axis. So you guys who are familiar with MasterSeries would know how quick and easy it is to set up those types of sections and do that type of thing in MasterSeries. This guy here is a UB with a channel coming onto the top of it. And further down here we have a nice double section. So that simply is very easily created in MasterSeries. It's just a checkbox for your standard UB to make it into a double section with the spacing. Over here we've got a plated section, or an eye section with a plate on the bottom of it. And then we've got another different type of double section, which is a C section, back-to-back C section. We could also do toe-to-toe C sections again, which weren't available in Revit. So that's all coming through there now as well. And of course these haunches were always a difficulty. You would just get previously have got your uniform sections through in Revit. So let's export this into Revit Structure, Revit Link Manager. Now I've already set up a link here. If you're interested in how to do that, there are webinars on the Revit Structure integration. You can have a look at that and see how all of that's set up. But simply, I'll just say submit the model to the link. Now I've got a nice blank Revit model sitting waiting to receive this at this end. So I'll just go to my add-ins. First thing you notice here is that rather than going to the external tools drop list, the 2014 version of the link gives its own nice prominent icon, just for you to find it a lot easier there. So clicking on that and coming in, and we'll simply say connect to an existing link, and let's go for this one, my link, and simply create new model from the link. So as this goes, it's basically going to be able to find all of these families. Now these additional families are installed with the, will be installed with the add-in tool. The MasterSeries Revit add-in install utility will copy all of these family files across to the appropriate directories on your machines. So here we have it. We'll just get that into 3D. Let's get a bit of rendering on the go here. Nice and shaded. What we have basically looking in on it is our built-up section, or sorry, not built-up section, but our compound section of an eye section with another eye section coming in on it. So this is indeed one of our bespoke Revit families. Also another section here, as you can see, coming in that nature. Let's have a look at one of our haunched sections. So we've got a haunched section here, and let's have a look at the type of that haunch. So basically you can do things like say, well, I don't have a haunch on the left, or I don't have a haunch on the right, and put in the haunch dimensions and all the section dimensions there. So basically, yeah, that's coming in there. One of the, I suppose, questions that people often would have with particularly haunch sections, this is quite important. I mean, the Revit default for the alignment of the physical member with the structural analysis line for beams, as we can see down here, is that the analytical line would be at the top of the section. And clicking on that, that's controllable. Obviously, you can say for that section that that its justification is to the to the top of the section, basically in these areas here. So you've got your Z direction justification to the top here. However, it is quite important to relay the placement of these sloping haunched sections in terms of their haunch depths and such. So we've modified this family here such that it doesn't do any cropping back, so that the measurement of the haunch is done accurately from how it is defined in your modeling software, and the same thing goes at the other end, as well as the section being automatically aligned to its center line. So with this information, basically, you have an accurate layout of how the actual haunch might or should be cropped and end plated, perhaps, if you want to get into that level of detailing in Revit, without wondering, well, is it actually moved? Because if we start to justify this to the top of this line, then that does adjust the geometry that's created between the column and the beam, and it differs then from what you have in your analytical model and also your haunch geometry layout. So glancing around here as well, we also have our double section down here as one Revit element. Coming across, we have our plated section here. So this section as well can say, well, we've got a plate on the top as well here, and our plate projection on the top, we're going to call that 75 millimeters as well, and apply that. And now we've got our plate projection on the top. Now that can be modified as well, where you would have a projection just on one side and not both sides. So that's all fully controllable from in that family type. And over here we have our nice back-to-back channel section as well coming across. So that element of the Revit update will really enhance your life greatly, I hope, and improve the detail of integration you get coming across. I'm just going to look back to MasterSeries. I did mention another aspect which we improved upon, and that's the level integration. Now we could bring levels to and from Revit previously. However, the level in MasterSeries didn't have any actual linkage to the level in Revit. If I change this level in MasterSeries, what actually would happen would be you would get a new level in Revit created at that. But now we're actually mapping, doing a proper linkage between the levels and storing the a proper representation of the objects between MasterSeries and Revit. So I just want to go in and make a level change here, and of course you've got the ability to go in here, and I'll just access it quickly through the area loading defaults to go in and modify your two levels. However, all that will do will modify the level itself but not the underlying geometry. I'm going to go in here and actually change the geometry, so I'm just going to go Shift X, Y, Z. Now, this is another slight improvement you might notice here. If I shift those nodes up by 0.5 and proceed with that, the actual level, when we shift a group of nodes, the program will make an intelligent decision to say whether or not actually a level associated with those should also move with it. So there's a certain type of checking, cross-referencing between the editing of coordinates and the level that might come with it. So that level's moved with it. You don't need to go back in and change that level now. I'm just going to come out of the editor, saving my changes, and let's just go into export, back into Revit structure, and just submit those changes back to the link. So back to Revit, and we're going to go back and enter our link and simply just say update the model from the link. And now we get simply a nice change in level, because in Revit these elements are referenced to a level and their whole vertical placement is based around the level. So we've been clever enough to know here now, well, actually it's just the level that's changed and not the coordinates of all these other elements, because changing the level will also change these coordinates. Previously, you would have got a long list of members which all have shifted by 0.5 meters in the y direction. So now this simplifies this a great deal when you're changing the actual level height, and you'll have less tidy up work to do afterwards in Revit. So we'll simply say OK to that and close that. And let's just look at that in an elevation. And now we've got level 1 has been modified to be 4 meters high, and obviously all the members have come with it. So some improvements there. Let's get ourselves back to MasterSeries and just show you another file there. And we mentioned the ability to take finite element slabs and walls from MasterSeries to Revit. Now I've previously just gone in and exported this file into a standalone exchange file just to do a one-time unidirectional exchange across to Revit. I should say that the bidirectional round-trip integration of walls and slabs hasn't been completed for the 2014 link, so you're still getting one-directional integration each way, but the round-trip integration, i.e. the updating of changes to and from, is still yet to be completed. So that will come later on in 2014. So let's get ourselves back across to Revit. Just create a new structural template there, and we'll just save that as well. Sorry, just saving that at this stage. And I'm just going to do a unidirectional import from, I believe it was in this test directory, slabs and walls, and we're happy to proceed with that. And we're now importing all of these slabs, walls, columns, beams to produce your Revit model with the levels, etc. also. So we're not too worried about that little message there, and we'll just go for a 3D view again with a nice bit of shading. And we're getting some tearing coming through on the analytical model, so we'll just go in and turn off the analytical model view. So here we have our 3D model coming through in Revit from MasterSeries with all of these types of objects now mapping across. And of course, as well as that, if you go and look at the analytical model, you can see everything is nicely connected as you would expect as per how it's actually set up in MasterSeries. So those are some nice new features in the Revit end of the business. Now I'm going to go forward here now and talk about some other new features in the finite element analysis. So back into MasterSeries. I'm just going to open up a different model in my little FE directory. Okay. Now one little feature that we've introduced here in this 2014 version, which a lot of you are going to find quite interesting, is the ability to model the interaction between columns and slabs with greater accuracy than we did previously. Previously, of course, slabs and walls are all connected together. However, the zone of interaction between a column and a slab was done just through the nodal connection. Now that presented some quite interesting challenges when we would then go through to at the analysis stage. You would get quite high moments occurring around these peak points, points of singularity. And we still have a very good way of dealing with those called peak smoothing. Now, to further that and to further the accuracy of that type of interaction between the wall and the slab and the column and the slab, we've introduced something that is a recommendation in this type of modeling called slab stiff column wall mesh regions. Now essentially there's a couple of different ways to implement this, and in your FE editor under global meshing options you can just simply say mesh column wall stiff regions and slabs for absolutely everything. However, I prefer myself to use something with a bit of control and fine-grained refinement, in that I can come through on a surface by surface basis and say that I want to So I've just gone into a new group of members for FE Surface 1. I'm saying here that I just want to model selected, or if you said as global it would do everything, or you could turn it off by saying no. But I'm saying I want to model selected, which essentially is everything in this regard. So I've selected the columns and also the edges of the walls that might be in question as well. And we'll see what this is going to do. And the similar thing has been set up for the other slab on the other side and also on the roof. So those 4 slab surfaces, we've told it what we want in terms of stiff column zone modeling. Now I've got some interesting geometries here. I've got some concrete columns, which are all actually positioned on the outer boundary, and they could be, particularly these ones, should be probably rotated and shifted inside the slab. We've got some rectangular sections in here as well. Now, if I just come out of this area and take the 3D off, now the meshing is still completed. I just want to go into, let's say, planet level 1. And what the meshing now does is it creates a zone of elements which match the borders of the interaction it sees between the slab and the column. So you can kind of see that around here and also around here. And what it does in those zones is it models a stiff zone. Those elements are modeled as a set of stiff elements rather than just using your usual slab thickness. They're augmented stiffnesses such that you do get a stiff zone of the slab around that. That gives you 2 distinct advantages, and one is that obviously you're getting greater accuracy and slightly perhaps shorter spans, as previously you'd have been spanning from one point to another, whereas now you're getting these stiff zones being modeled. But the other advantage is, if I go and look at the output, is if I start to look at my analysis output, these stiff zones, we now have an accurate representation of the perimeter of the column, and we only look at the results in the normal areas of the slab and not inside the column head, essentially. Previously, peak smoothing would have sorted out a lot of that for you, but now with this you get peak smoothing is just done on a circular basis, but now you're getting an accurate picking of the values around those locations. So the peak smoothing, although it's turned on, isn't actually picking up any peak points around these locations because they've already been, the stiff column zone is taking account of that. So essentially, if I just turn on a little bit of 3D here, you can see the effect that that's having. So you're getting much more reasonable interactions between the slab and the column, and more accurate modeling of those zones of interaction. And you can see the same thing coming through here for the wall. And interestingly, if we look at the roof, the roof doesn't have the opening, so therefore you get the thick wall being modeled on both sides, and the effect that that has as well on the actual stress is quite significant and beneficial. So obviously you still have your things like your strip averaging, which will take account of the fact that you're strip averaging not the values inside the column stiff zones and things like that. So that'll all be taken into account and taken and appropriately accounted for in the strip averaging. Another nice little new feature we have in this version is the ability to we've always had the ability to place values at characteristic points. I just put that back on a flat view. However, sometimes you might want to know, well, what's the value in here? And this isn't seen as a characteristic point because it's not a peak point or anything like that. Of course, you could try and pick up its value from the contour. However, we have this nice little facility here now. Actually, just as you hover around, it tells you precisely what the value is at that point. So if I want a value here, picking in there annotates that value for me, making my life a little bit easier there on that. Of course, the section diagrams would allow you to do stuff like that as well, in terms of drawing a section diagram where you want it and picking up values. But this is a nice little facility to do that type of thing. Now, Moving forward a little bit, another nice new thing in the finite element analysis is the ability to not just pick up forces, whereas previously you've always had the ability to look at forces in the members, in the shell elements, i.e. the in-plane membrane forces and moments. Now we have the ability also to look at stresses. Now you might look at something like this and go, well, I don't really need the stresses, the moments and forces, and this is all really I need. But some people are using our master frame finite element analysis for more structural components perhaps, and they are interested in the stresses. Glass is something actually we find that is something that people are modeling more so, and they're wanting the actual detailed stresses. Let me just show you a little bit of a model which demonstrates this quite well. We have a steel plated component here which was put together by one of our users, which models an interaction of a group of steel plates with some interesting loading conditions. Now another nice little facility we have is something called point lighting as well in this, which has come on board with the new DirectX technologies that we can use, and it does sometimes help to put a nice sheen on things, but that's just a little side issue that came to mind there. So I'll just turn that point lighting off. So let's go and look at the output for this into the graphical output. And I think we've got a very fine mesh here, so it's quite a considerable amount of contouring to draw and such. So we'll just go into shell elements. One of the things I want to do here is just go into my finite element display options. Naturally this isn't new, but it helps me here, and just say don't draw the mesh. Let me just see the plane geometries, and into shell elements. What I want to do as well, I'm just going to filter down to an FE surface on the top of this slab as well. So what I want to show you is basically the ability to draw stresses here as well. We can investigate. But basically now we have the ability to look at a series of stresses. So obviously your direct stresses, your shear stresses, but also principal stresses. But the one that a lot of people might be interested in for this type of application is your yield stresses. Adapted to different yield criteria, so whether it's von Mises or Tresca, or the other ones for the brittle type materials such as the Drucker-Prasher or Moore-Coulomb, or the stress criteria which where you've got a lower tension capacity than you have a compression capacity. And there are actually newer inputs in the material definition, so if you are wanting to get these types of stresses for the brittle type materials out, in the input of the finite element material property, you get to specify what the compression and the tension yield stresses are for your material in order for these equations and yield surfaces to produce what you want them to produce. So as well as the stresses, obviously also you're interested in what side, so you can say whether it's the positive Z side, the negative Z side, or the mid-plane, or even indeed the maximum absolute value of stresses from either side being presented to you there on that. So those stresses are something that I think a lot of people have been looking forward to, and hopefully should be of good. Okay, another nice new feature is something that you might sometimes get when you're doing alternate load regions. You might analyze a structure and it tells you that a certain number of elements haven't been found in an alternate load region. Saying no to that will show us which ones they are. What the situation is here basically is we've set up alternate loading on our slab to cover all the different patterns of loading that we might want to consider. Our density, our basic material density load group for FE has been set to be the alternate group as well, which means the walls don't know, because they haven't been set in an alternate region, what load group to be associated with. So we have this new feature here to simply say that we want a default load group. So anything that isn't covered in any one of these regions here will end up in load set 0 now. And all I've got to do then is, in my load cases, in my combinations, is simply say that I want to include for load set 0 there as well. So analyzing now will allow us to continue without that error. So that's just something that you're going to find very, very useful. Previously, people would have set up the separate alternate load set 0 for all their walls, but now you don't have to do that with the default option. Another new thing which was introduced partway through 2014 or 2013 was the ability in the FE editor to have attached beams which were produced at an offset. So we have here an attached beam at an offset. That's either at the bottom or the top. So we can see as we come around here that this beam is actually placed at the bottom. Now that's not new, that did come out, as I say, partway through 2013. What is new is now the ability to have different types of offsets and dimensioned offsets in the same slab. Your 2013 version, basically you had one set of data for the entire slab. So if you had beams over here which were in the bottom, and for some unusual reason you had beams over on the side which you wanted to be on the top, you could place them in a separate attached beam group, say they're on the top, and select them also. So that's going to be something that's quite useful there if you have those types of conditions. A couple of new features in MasterFrame before we then hand you over to Michael to do some review of our dynamic analysis. Twenty 2013 saw a significant step forward in terms of our member drawing capabilities, in that we've got a much more CAD-like interface whereby you can have grid lines and the likes. Now that's not new, but we have a new feature here, something called auto tracking. I'm just going to turn it off for a second to demonstrate as a little recap of what tracking actually is. What tracking is basically the ability for you to say you wanted to snap in a line which projected from or was aligned with that. The tracking basically allows you, just like in many CAD systems, it's just to hover over that point, and then it basically gives you tracking points which pick up. Likewise here, if I were to hover over this point, I now get tracking points which go along here like this. Now, for drawing something very quickly, if I wanted to just draw something out there very, very quickly to align itself with all of those beams, yeah, I mean, I could just spend literally more than a few seconds picking up those tracking points. However, rather than always having to do that, we do have the ability to now turn on something called auto tracking, which is on by default. And what the auto tracking does, it'll look at where you're snapping at and choose automatic points in the proximity of where you are. So now you can see those points. So I can extend from that or project from, say, this member, and you get a whole array of interconnecting lines automatically picked up for you. So if I wanted to go out here and just very, very quickly snap in a series of lines which coincided with those points, oh, a little bit of slip there, I can quickly do that with my auto tracking turned on. Now what I would say is that auto tracking does work better when you don't have too many things in your current view. So yeah, get yourself to a floor plan view or something like that. Using the auto tracking, say for example in a full 3D space where you've got lots and lots of objects all vying for their tracking priority, with the auto tracking could be a bit more of a challenge. So it might be something that you'd want to turn on and off, or it might be something obviously you find more useful when you're just working with a subset view. Now, I also wanted to review or look at one more new feature which is reasonably significant for the 2014, and that's the introduction of the SCI P385. We've always had, as I say, the ability to go with SCI P57, which obviously is applicable to the British code, but for Eurocode there wasn't any compatibility between the 57 and Eurocode. Along came SCI P385 and filled that void. So quite simply, I've got some torsional eccentric loads on these edge members. I'm just going to go into steel design. And there's probably not a lot to show you here apart from it just does it. So I'm looking at a channel section here. It's picking up the fact that I've got torsion design and presenting all the nomenclature according to the P385 and calculating some extra things there. It does go a little bit further in terms of various different things, like these K factors are new to the 385, which are all automatically calculated. The other thing that we introduced during 2013, which you do have available in your version today, but was introduced partway through 2013, is the ability to model what we call stiff deck using a semi-rigid style stiff deck. So if I go to my properties and special properties, when we go to this stiff deck semi-rigid, I can see I've modeled in this structure a stiff deck subset, which basically was done by picking a group of members. So if I just clear that, go into the first floor, and I'm just going to say auto select just the main borders of what I window. So windowing that, it recognizes that's the main border set of members. And then what we can do then is create secondary internal borders. So I can window this little set of members in here, or this set of members, to create an internal border. So at this point I'm going to hand you over to Michael, and he's going to take you through, in the few minutes that we have remaining, some of the new features that were introduced in during 2013 in our MasterSeries dynamic and seismic analysis.
Hello everyone, my name is Michael Dowd. I'm just going to present very briefly here and talk us through some of the dynamic analysis features that have been incrementally introduced into the software over the past year. So these are all features that are available in the software in the latest patch. First I want to outline some of the main tools that are part of the dynamic and seismic add-ons. So we have a modal analysis engine for natural frequencies and mode shapes. We have a variety of very powerful time history analysis tools that could be used to model loads like vibrating machinery or sort of complex dynamic wind loading. Or we also have the seismic add-on, and this includes some lateral force method calculations, the response spectrum method, and a full time history analysis with base accelerations. And finally, we have the response factor tool, which is becoming very popular, and this can be used to limit the sort of vibration response of your staircases and floors. So here's a list of some of the features that have been introduced over the past year. Some of the key ones, I suppose. Finite element surfaces. This is the biggest thing that we introduced in the last year. So it's now possible to dynamically analyze models with FE surfaces, and this includes composite floors or slabs with attached beams, like Martin was showing you earlier. We can do shear walls, and anything really that you can model in finite element surfaces can now be dynamically analyzed. We've introduced improvements to how the dynamic analysis uses memory. So as Martin mentioned earlier, the 64-bit version of MasterSeries is one of these improvements, and this will allow the dynamic analysis of models of practically any size, limited really only by your computer's hardware. So we also have the response factor vibration design tools, and like I said, these are becoming very popular, and I want to go through a nice, quick and easy example of how to do this in a few minutes. We've also revisited how mass is added to your dynamic model. We made the process a lot more flexible and hopefully more transparent, so users can now define their own mass or have mass series calculated automatically, or any kind of combination of both of these approaches. And we've also improved one of the time history analysis features, which is called our snapshot. And this allows users to capture the forces and displacements in their structure at critical moments and export these to MasterFrame for static analysis and design. And we've added features that make it much easier to generate these snapshots at the critical times. And I'm going to go through an example of this shortly as well. And this feature, we're hoping users can use it and will find it useful for calculating stresses and designing members with added loads due to vibrating machinery or wind loading or waves or any kind of dynamic loading. I also want to show you a quick video here of a frame a user sent in being put under a seismic load in our base acceleration time history analysis. So this is just zooming around the frame just to show you it's a decent enough sized frame, and I think it's a industrial kind of steel frame for some sort of to support some sort of machinery. And you can see down here we've got our seismic base accelerations shown in a little graph here, and this is the progress through the earthquake that is being applied to this model as we speak. Okay, it's probably not coming across as smoothly as it is on my screen for you guys if there's a bit of lag, but yeah, you'll see in the video online that basically this has been rendered, so it's a nice, it's just showing representing the structure responding to the earthquake. Oh. And finally, just the final part of the slideshow before I do a few examples, I just want to show you some of the output that we can generate from the response factor analysis tool. So these are a couple of models users have sent in, and you can see, well, these two graphs, it's when you look at a particular kind of node or degree of freedom in your model, you can sort of see how it's responding to a changing sort of input harmonic force frequency, and you can sort of spot at what frequency it's going to have the highest response. Or you can look at the model overall, like all the nodes, and sort of quickly use the colored contours to spot like the critical parts in your model that are going to be the bounciest. So these are a couple of stairs that we've been looking at, and here's the floor. So now I'm going to just go through a couple of very quick examples. First, I want to show you a bit about this dynamic snapshot and just how you might be able to use it to actually do practical and real kind of design work. So here's another model we've got in from a user. Just a very simple frame. Again, it's an industrial thing that is going to support machinery up on the top level. So when you come into Dynamics, the first thing to note is the modal analysis tab. This is called natural frequency tab. So this is important. You need to have done a modal analysis before you can move on into any of the other sections. And in this case, the model already has one performed on it, and you can tell that because the list of mode shapes is shown here. And you can click these and see the mode shape rendered on your screen. So we'll just move straight from here, and I'm going to do a steady state analysis on this. Basically, what I wanted to model here was a machine resting here, vibrating on the model. So I've applied a harmonic force at each of these points here with a frequency of 10 Hertz and an amplitude of 3 kilonewtons in the Y direction. And we can see that load represented here. And the thing I want to show you to focus on is this snapshot feature, which basically it's going to collect the nodal displacements and member forces in your structure at a particular time. And when we have that information, we can send these back to MasterFrame and sort of attach them to a standard sort of static load case. And then when you analyze back a MasterFrame, you'll be accounting for this extra dynamic load that's on your structure. But the key thing, and we sort of changed this recently, is that users were struggling to find the critical moments in the time history analysis. I mean, with a vibrating machine, you could guess that the worst case scenario for beams around here is going to be when the load is highest or lowest. But what we've introduced is actually a way of automatically calculating these. So we can say we want to look at all the min and max member end forces. And we can also actually just select a level, so we don't need to look at the whole structure anymore. So in this case, I've actually got the level selected. I'll just show you. You just window the level like that. And so now it's just going to look at the min and max member end forces of this level, and you can say automatically generate snapshots at the times that those min and max occur at. So then all you do is press play to run your steady state analysis. So you can see this is the floor vibrating under the machine load, which is a vertical kind of harmonic force. And these min and max end forces are being generated for us. And when it's done, you can go and look at your snapshots, and it's automatically taking snapshots at the critical times. So we think this is going to be very useful, and we know a few users have been using it as well to basically design for the extra load that's on these members due to that vibrating machine. So you can actually work with this snapshot and this min-max tool in any of the time history analysis things. So even the base acceleration tool I showed you a second ago, or the force profile, which allows you to model any sort of dynamic load that sort of changes over time. So that's that. Now I want to show you another example here. It's going to be just a nice quick floor for the response factor. So just a basic sort of model here. One of the nice things about it is it's using the dropped beams attached to the FE surface. So these are, and it's got a nice kind of array of primary and secondary beams here. And these are all modeled as sort of attached beams in the finite element surface. Also just want to quickly point out just the mesh here. Now this is actually the mesh itself. It's very kind of coarse. It's not a fine mesh at all, but this is kind of quite good for dynamic analysis because we're actually using 8-noded shell elements. So this mesh here is actually a lot more accurate than it would first appear, and it's more accurate even than if each of these elements was divided into 4 smaller 4-noded elements. I mean, what we have here is actually more accurate, and it's more than accurate enough to model the dynamic behavior of the floor as well. So jump in with this model into dynamics. And first thing, again, it always comes into the modal analysis, and again this one already has a modal analysis performed, so you can tell that by the mode shapes here, and we can look at the modes. First one here is actually a lateral sort of mode shape, so it won't really be of concern to us in the response factor, which is more concerned with vertical vibrations. The second one will be definitely of interest, and these sort of ones here as well. They're all vertical mode shapes. So we go from here into vibration design, and once we're in here, I'm just going to briefly go through how you do a very quick calculation here because it might be of interest to some people. So the first step is to add a dynamic load case, and the idea with these load cases, you can add more than one and kind of compare how different options affect the results very quickly that way. And we choose the SCI P354 approach. It's the handbook. General space, give it a damping of 2, and over here is where you choose your the forcing function, the sort of Fourier series, and these are all taken straight from the handbook. So we've got walking, and we'll apply it in the range of 1.8 to 2.2 hertz. And just to get a general idea of the overall structure's response and where the key areas are, I'd usually go with multiple nodes and just window the entire structure. And we can choose to use all modes, which would be the most accurate, but that can take a while and it might not be necessary. And also one thing I want to show is how the response factor kind of changes, and it's interesting to see how it's affected by using different modes as well. So just have a look through here. Let's just calculate a response factor based on using the first vertical mode here and see what we get. So you just click vibration design, and you can see straight away the colored contour is going to highlight the key area, and as you'd expect, it's where the mode shape is biggest or most active, and we're only getting a response factor at that key area. We can click it over here and it'll highlight it on the model. So the worst response factor here is 6.8, but I also wanted to just have a quick look at how the response factor changes as you add more nodes. So we'll just have a quick look through and see what other nodes we can add. So I'm going to add 4, 6, 7, 8. So just add these modes in and see what happens. And then we just vibration design again. And you can see I just find it very interesting to see how the critical areas can shift as you start to take more and more modes into account. And indeed, if you were to take all of them into account, this is actually where the critical part of your structure is. So like that's the sort of area you need to really focus your attention on if you wanted to reduce the response factor. If we just go to a 3D view, we can actually see why. It's because the beams here are actually like kind of quite slender for like a humongous span, so it's just interesting to see that. And yeah, the response factor shot up in these areas. It's 33.3. Anyway, so just thought that might be interesting to have a look at. That's pretty much all I was going to talk to you about today. So I'll pass you back to Martin now. He'll just finish off.
Thank you very much for that, Michael. That was just a review of some of the extra stuff that Michael's been working on throughout 2013, and all of which is available to the 2013 version today. So just remains for me to say thank you very much for your time here today, and we apologise for running a bit over on time, but hopefully you will be able to get your hands on these new features very soon. As I said at the beginning, if you're interested in participating in the beta testing, drop us an email, and we'll be glad to add you onto that program, and we'll get you a version of the software as soon as that's available for that phase of testing. But hopefully, as I say, within the next 3 to 4 weeks, we'll be rolling this out to the entire user base. And well, we hope you enjoy using your MasterSeries 2014. Thank you very much.